Namaste. I welcome you to the module of Semantic Web. I am Manoj Kumar, scientist from InfluMnet Center. In this module, we will be discussing about Semantic Web. You are aware of web. The website is very common now. Even a literate man or people can understand what is a website now. Semantic web is something beyond the normal website. In this module, I'll be taking some of the technical terms, but please do not scare away from these technical terms, which is not very essential for you, but to give justice to the complete technology used for semantic web, I will be using these terms, technical terms, and some of the languages used in semantic web. Website, as you know, let us first start with our website. The normal web we use, which is syntactic in nature. So there are two kinds of website. One is syntactic website, other one is semantic website. Since we are not using syntactic website, syntactic the term with the website, it denotes that we are using only web, not syntactic. So that syntactic is not required to use with the common website. But when I am referring to website, it is nothing but syntactic web. Syntactic, in a sense, we have two kinds of writing when you are understanding or the writing skill. There are two kinds of pattern which we use in creation of content. One is the syntax of the statement, syntax, and other one is called the semantic, the logic of the statement. Rama played football. In this statement, you know that what is noun, what is the verb, what is the predicate, what is object. Everything is clear on this. Rama played. And grammatically, syntax-wise or semantic-wise, both ways it is correct. But when I use football played Rama, in the English language it is correct, but logically it is not correct. So that is where is the difference between syntax and semantic. So giving meaning to the current website is called semantic web. So content we use right now is syntactic in nature. Typically it is nothing but information which is stored in the website, seeking, publishing, using, and searching it for the people and product, shopping, reviewing catalog, and watching movies, go to the video streams, and listening to music. Everything is possible through the normal website. And these websites generally, these are created static in nature. Now a syntactic web is created just by connecting the information through a link. That links are called hyperlink. And in technical term, we tell that we use a protocol called hypertext protocol, HTTP. So any web address or for a common website, we will see that HTTP, hypertext transfer protocol. And that is nothing but arrangement of lot of web pages, organized web pages by giving hyperlink to other page. And we use a language for this called HTML, hypertext markup language. So what is a website technically or common website is nothing but the content or information created by using HTML, which is linking with many pages, and this can be viewed in a browser. So hyperlinked documents are the current syntactic website. From the slide href, that is one place you can refer to the next hyperlink. So this is what is normal syntactic web. So a user need not know whether he is using syntactic web or semantic web. And what is the problem with syntactic web? Syntactic web will take the data which is visible. What you see or what you store is available for the user. So user type a URL, address, and he get it on the browser as it is shown in the screen. So the markup consists of that rendering of this information into a browser. The information which we type, which we store, which we preserved is formatted to give to a display to a browser. That is what is at the syntactic website. Content is available. Now let us see what is the problem with syntactic web. Syntactic web or the normal web is designed only for common man or to human being to understand. Common man in a sense the user I am mentioning. It can be common or intellectual or academic. And the user when he sit, he type it, he get the content as it is. This is the normal way of working in the website. Here the web will not put any intelligence into it. Now the semantic, as you can recall, the web is invented by Berners-Lee, and the semantic web concept is also he only introduced. So instead of people understanding the information, it is desirable, it is appreciated that a machine should read this information and interpret it. That means any content stored, another machine can read and interpret. There we should give some logic. Otherwise, generally the interpretation is done by the user. Instead of that, machine can. So here I have included a slide which shows that I know what you mean. Means the machine can understand what is stored. That is what is semantic web. Now let me define it in a simple word. Semantic web is an extension of current web in which information is given well-defined meaning. Semantic means meaning. So meaningful web, you can call it as semantic web is nothing but a meaningful web or an intelligent web or a deep web, whatever you call it. So define meaning and better enable computers as well as people to work in cooperation. So this is what is that semantic. Berners-Lee defined this in 2001. That means we are almost 15 years talking about this semantic web. So it's nothing separate from the web, it's an extension of the current web to create a semantic web. Now how it is possible? We store a lot of metadata. When a web page is created, the page description about that page, metadata is data about the original data. And that metadata is defining clearly to get. In the picture I have included, suppose what the hell we are talking exactly. So some of the words I removed it and I store what exactly we hack. And what is the relation with is the other one. This is what is defined separately, that so that we create kind of phrases or words which separate itself and define the meaning between this. So that Rama played football, if that is the word I want. So Rama is separated, word played is separate this, and what football and Rama will be, what he did, played. Even tomorrow I can pull Rama kicked the football, or Rama pick up football, or Rama heads football. So all this can be stored as a relation between these two. So this is how the semantic concept is evolved. So semantic web is a web of actionable information. The information derived from data through a semantic theory, that is putting a logic into the data storing technique. Semantic theory of interpreting the symbols. So it's a concept which makes possible to organize available web information sources and to use them not only by syntax or structural method, but also by the semantic methods, logic methods or meaning methods. So the word semantics stands for meaning, logic or relations. Now definition, a simple definition. We can define semantic web as the web which can provide search result in a semantic meaning. And one example I just want to tell you that, suppose you take a search engine, you type Apple in the search box. Now Apple can be what a user intended to know about Apple. The user is able to get data about the fruit apple or the company Apple. Apple is a very well-known company, iPad, iPhone, all this. So how do we recognize this difference, whether it is fruit or this? There should be a relation. So that relation should be spelled with each word. So that is what is that, this is semantic meaning. Search engine can understand the meaning of search linguistic element, the term used, by analyzing it and show the result in a defined way. So Google, we have heard about it. Google is a search engine which can search into normal, syntactic, common web. And I give an example of semantic search. Soogle, SWOOGLE, Soogle is a semantic web search engine. This, when you go to Soogle, it will give you all the ontologies. The word ontology I will define later, which is one of the component which can make semantic web. Now, why do we need semantic web? Because objects or the documents are described differently, and building a system where machine can analyze search time, understand its meaning and interpret accordingly. Does it sound something like very magical that machine try to understand the meaning or word or the relation? Now let us look into that, how this is that. How to add simple semantic things into the data. Let us start with a weak semantic to a strong semantic. Now, a simple HTML, which is a static data, you don't have anything on the HTML. But if you add little bit of glossaries, thesaurus, that means when I am talking about some synonyms, I search, if there is a thesaurus or glossary telling that, this is also meaning that. So that same word, when I search, it can be looked into different context. So glossaries and thesaurus adding is something like website, is you are adding a little bit meaning into that. This is what is where we call it as weak semantic. Now, if you are adding controlled vocabulary or data model separately, like enterprises data model, taxonomies, and at the end, nowadays, recently, the best semantic model is coming out with a model called ontology. Ontology is not a new term, but ontology using in semantic web is now experimented. That is what is the highest degree of semantic achievements now. Now from HTML to implement vocabulary and thesaurus, we can go to an open format that is called XML or the XSLT, that is extensible style sheet, the markup language style sheet. And then you can give each individual, every word or every relation you are using, you can give an XMI or UML. Then this has to be defined in a format which can link each other. So normal HTML will not work for it. For that, what is required is we need something called RDF. I will come to give an example of RDF later. Resource Description Framework. This is what is required from HTML to move into semantic model. After that, now recently a lot of languages, markup languages or special languages are introduced for creating these kind of ontologies as well as semantic web. That is what OWL. So in this talk, we will quickly go through all these terms: concept map, OWL, RDF, XML, all this, starting from this. And this is what is the technology used on that. And goal is provide common framework to share data. Web across application boundaries. That means between application, data should be shared, not between people and the website. So main idea is to try to understand the layer, standard, and the ontology model. Let me refresh the points once again. Web was invented by Tim Berners-Lee. He was a physician working in the CERN laboratories, and after some time he also introduced the reality of syntactic web as well as semantic web in his concept. Now looking the architecture of semantic web, the user may be directly interacting with the content, and there should be between user and this, there are certain layer of architecture level. One gives about the trust and proof, that is predefining the data or giving more meaningful data, trust and proof, then unifying the logic between this. Then you have to use one kind of language there, either it could be a rule defined on that between data, and ontologies which directly create this kind of relations, and taxonomies by using RDFs, and data interchange framework, that is RDF. Then it can be stored in an open format called XML, and everything will be having a URI, Uniform Resource Identifier, and this can be on multilingual if you are giving Unicode, and all this will be in a kind of cryptography. That means it can be stored as you want in any security. The complete architecture of semantic web. Now let us look what is ontology before I go into the RDF and XML. So these ontologies describe what we mean in some ways that machine can understand. It's a standardized way of modeling the ways different pieces of data relate to each other. Ontologies have been around for decades. It's a philosophical term, ontology. But the increasing interest in sharing over the web started with this semantic web. Ontologies are simple thing. Let us take another example, like Rama played football. Person, food, and there is a relation between person and food. What is that? Person eats food, or person think food. So this use kind of triplet, subject, object, predicate. These are the English common language symbols. And we tried to semantic web, we tried to implement this triple concept of three, subject, object, and predicate kind of things in the semantic web. If you are going to detail of that, ontologies may look very complex. Looking at the screen, you see that there are a lot of lines like HTML, RDFS, RDF defined, URI defined, and all this look like it's a complex programming language. But these are all very simple to understand if you really understand how these RDFs are created. Now, how to create relations? I have to take it from a normal example. Let us take a kingdom called animal. This is the ontological model I am describing, how to create relations. Now, animal is a kingdom, top domain. Now, animal can be of two types. One is skin animal, everything covered by skin, or it can be flying animal. Then you are defining that travels by flying, or suppose if I am taking one example of bird. Bird is an animal. Then fish. Fish is an animal but travels by swimming. So travels by is a very common term used, but between fish and bird it very differ. That covered by skin. Then we have ostrich. So we'll tell that ostrich is a bird, penguin is a bird, canary is a bird. Again comes that color of canary, it could be yellow or red. Or then there is another instance of penguin. One is a penguin generally walks, travels by walking. So all this defines in a various way. For that we generally create this kind of ontological forms. Now ontology theory, the semantic web actually is required for knowledge representation. Knowledge is as a set of concepts. Information is completely scattered, but knowledge is very precise for decision making. So knowledge as a set of concepts with a domain and relationship between these concepts. Or generally if you go by any definitions, you can see that ontology is nothing but formal, explicit specification of a shared conceptualization. The definitions seem to be a little technical, but formal means what? You are declaring it. Explicit specification of shared, how data is shared, a concept you make it that can be shared between people or machines. So shared conceptualization. The structural framework for organizing information and are used in semantic web. Some of the examples where semantic web are used: artificial intelligence, systems engineering, software engineering, biomedical informatics, library science, enterprise bookmarking, information. And why we talk the semantic web here? Because it is extensively used in library science. Now every information web resource is named as a URI in the context of semantic web, because URI, Uniform Resource Identifier, is a piece of data. We know that URL can be represented to make an address. URL also can represent to an image in a website, but URI is the concept where the different terms like animal kingdom, birds, it could be a URI for bird. Then it subsequently derive the other relations, that's universal. So it's a universal naming for web resource, same as URI, or URI are the ground terms for semantic web. Most important use of URI is that it provides understandable identification of all resources in distributed internet systems. In that means if I am connected with 100 machines, each piece of information which is uniquely can be identified URI. I can use somebody's information in my semantic by just referring that. That's why URI is very important. Then semantic web is created by using Rdf threshold. But before Rdf, the normal HTML has to be converted into XML. XML is an open format. XML stands for Extensible Markup Language. This is a user-defined domain-specific markup language used for those documents which have structured information. And XML can have a namespace, allows to specify different markup vocabularies in one XML statement. So you can also see that there is a namespace, Rdf vocabularies as mentioned, there is a namespace, XML vocabularies are specified. So if it is Rdf is using a namespace, you can use Rdfs for that. Now XML was designed to describe data, similar like HTML, but XML tags are not predefined. The tag I can define. An animal, I put a tag. Book, I look at tag. Title could be a tag. Thesis could be a tag. So I define, the user defined it. So we must design our own tags. But in HTML, please remember the tags are already defined. Body, HTML, Ref, href, then h1, h2. All these are the predefined tags in HTML. In XML, we define the tab, but the way is same. Angle bracket is used. And XML also uses DTD, document type definition, to describe data. So XML plus DTD combinedly design that how this can be displayed. And XML with the DTD is designed to be self-descriptive. So XML with the DTD, that is self-descriptive to pass on to as a complete data content set to other. It shall be easy to write program which process XML. So between machine, since it's an open standard, machine can understand XML. Only browser can understand HTML. But XML cannot be directly displayed on browser. XML only machine can understand. The formatting language, machine has to decide how it can be. But XML can transfer. So XML is the markup language for exchanging data in open standard. XML design should be prepared quickly. The design of XML should be formal, concise, and document is very easy to define. Let us look at the example which is given here. I want to define, because we are from library, I want to define book. So book will have title, author, first name, last name, then edition, place, publisher, then the physical description, how many pages of that, and this is. So what I am going to define, first I will tell that this is an XML document. How do I tell this is an XML document? By putting angle bracket, question mark, XML version equal to, then 1.0, then what is encoding standard, UTF-16, UTF-8. When I mention this first line, the machine understand, oh, what is coming now is an XML document. Now, once it understands it's an XML document, it will look for the tags. So immediately it understood there is a tag called book. Then there are similar sub tags in that. So title is there. So if it is book, there will be so many titles on that. So book is a table, and video tab can be, serial can be another than. This is how we can look or design the XML document for our collection. So simple example. Now let us see what is Rdf. I hope that XML is clear to you. And now Rdf is a simple conceptual data model. It's defined by the W3C consortium. You know, any technology which is introduced, this has to be accepted by a standard agency. That agency is called W3C. And Rdf model, it is all definition comes from the set of Rdf triples. Earlier I told subject, predicate, object. SPO. For you to remember it, subject, predicate, object, SPO model. Now this triple, it's an expression or a statement. So for what we have to do, we have to subject, we will define the resource. Predicate, we will tell the property, and in the object we will define the value, that value of the property. And that is how the Rdf is prepared. We will see some examples now, how triples. And I am taking an example from W3C itself. Rdf is for creating relation between document. It consists of triples or sentences in the form of subject, property object. Now let us put a tag called Mozart composed this music. You know Mozart is a musician, Magic Flute is one of his album, and composed. So Mozart and Magic Flute is something like subject, object. And what is the property? It's the relation, composed. I can write written, Mozart written. So composed will be replaced with another word, but the other will be there. So this is how we create the simple RDF document. And there is an RDF-S also, extends RDF with standard ontology vocabulary. So if you want to use two ontological terms with RDF, we need to use RDF-S, where the extension include class, type, domain, subclass, property, range, etc. Because ontology is like creation of all relations. So we need more terms to connect each other. And RDF provides metadata about web source, object attribute value triple. It is similar to the XML syntax, and the chained triples form a graph. Now here, look at this. I have an URI there. Hashman has an email of this. So has email is a relation, and this is a very simple thing. Hash name of the person has an email called his name @ nothing. I have taken a common example from the web. Now how to describe this? I write this is RDF, so RDF first and colon description, then RDF's about, then has mail, then the mail content, then description ends here. So I have put the data in between this. Who RDF about equal to the name Payam. So this is how a simple RDF is created for this data to represent. Now this is another one, has honor. He has a teaching experience. Now all three is combined now together. This man teaches the subject, and he is the owner of this institute. Like that we are creating relation. This can go like a university system later. Another one, he has an image put into, he has an image that is a common photo which can be referred, and anybody can refer to that when you are giving that URI. So in earlier example we are able to understand every resource has a URI, and URI can be a URL, that is it can be similar to your address, and identifier does not necessarily enable access to resource. We can think of resources of an object that we want to describe, either a book, person or places. Now these are the RDF basis properties. From the example you had seen, properties are special kind of resource, relations are, and it could be like written by, composed by, etc. Title properties, all that examples of properties. And statement can be like a object attribute value, simple full word, this man published this, and that is how RDF example is defined. Now the full RDF which is already there shown is like this. I just request you to go through it and try to understand how this has been created. Now there are two sets of description now. One is the top and second is third, and third is also there, one small one. All these three steps are defined in RDF. Now machine can understand this. And earlier animal example which we try to create something like this, where, and you can have a common definition of all this in any site. Nowadays many of these are already predefined. So if you want to work with any of this ontology, you have to just refer there, take the content and redefine it. So this is one example RDF statement, again subject predicate object in the same way, value properties, and graphical representation in RDF. So who is the creator, what is the description, who is the contributor, all this can be related, and data and this is related each other. This has been prepared by one of my friend for teaching the semantic web, so I took the example from that. And RDF representation, that same thing is represented here in a different way. So I'm not going through to the line by line, but you can understand first one is RDF XML namespace, from a common namespace used. then Rdf, these 3, 4 are there whenever we are creating a new document. This is almost fixed. You can refer to any places. Now Rdf XML is over. Now let us see that how we can use taxonomies and ontologies for the semantic web. Both terms are used almost in same context, taxonomies and ontology, but there is a taxonomies on ontology. Ontology may include many taxonomies, that is the difference. Rdf schema is used to develop taxonomies. Now example of a taxonomy. You have the Animalia kingdom and non-chordate animals and chordate animal, then fishes, amphibia, reptiles, all this comes into that chordate one. Protozoa, coelentera, porifera, all this nematoda, all this comes into non-chordate data. This is the animal kingdom, something from the biology. So how this taxonomy is arranged, that is shown here. Now ontology studies existence of entities and their relationship. Groups are formed due to likeness. So we create, so furniture can be two types. One is wooden furniture, another one is steel furniture. So all wooden furniture we classify into one. This is how ontologies are created. Now this is an example of ontology created and its relationship. Now I will come to this later with a just example to understand. Now from here we can understood shared conceptualization. What is ontology? It's a formal explicit specification of shared conceptualization. So conceptual model is there, expressed in true knowledge representation, and for ontology there is a special language. It is a scribbled acronym, web ontology language scribbled as OWL. So ontology is created by using OWL and RIF, SWRL, these are the additional languages. Just for the namesake I'm telling these words, but don't be afraid of the technical terms because people are not very quite, or even technology developers are not using all these terms for the development. Now earlier examples I have shown animal and all that. Now from here web ontology or OWL are three types. This can be OWL full, OWL DL and OWL light. And RIF stands for rule interchange format. It is used for creating rules. Rules mean inferences that can be drawn. So there are a lot of inference engines available in the software itself, reasoner I should say. Data can be exchanged based on the reasoner. It works primarily with the rule layer. It has been evolved and maintained by W3C. SWRL is Semantic Web Rule Language. It is a proposed language for semantic web and can be used to express rule as well as logic combining OWL. I have not worked with the SWRL since this is very evolving now. It's not matured as such, but this OWL DL and OWL Lite has this kind of rule markup language. Now when you have all the data available, we have to ask to get the data. So we need to have a query language for that. I am sure that you might have heard about SQL, structured query language, which uses to get data from relational database or any database management system. But if you want to take data from this kind of semantic, we need to use one of the technique is that use Sparkle. Sparkle stands for SPRQL. It's an acronym again, abbreviation. Sparkle stands for Sparkle Protocol and Rdf Query Language. It's a query language to retrieve and manipulate data stored in the Rdf. So Sparkle is used to query Rdf format data and get the result. So Sparkle combined with Rdf can get the data for the machines. And we need to have some proof or rules layer. It is for performance or perform the inferences over ontologies. Rules as a tool for capturing further knowledge. And trust layer is the top layer in semantic stack. It should support provenance and trust. Provenance means where does information comes from, how this information has been obtained, can I trust this information? All this is what we call provenance. Now provenance is the part of trust layer. Trust is largely an unexplored issue because we can't 100% tell that this data is from this site which is very authenticated. There is no standardization of it, but there should be a trust layer in defining this semantic web. And there are two types of tests. One is reputation based trust including rating system. If everybody is going for a particular data to some site, we can take it as yes, it is a reputation. Then context-based test, use background information. Then content-based test, information content itself, together related information published by other information, Wikipedia. Maybe we can take it as a content-based test. And with this, there is a lot of promise for semantic web. Semantic web can represent information, categories, etc. I don't have time to show you one of the tool or any tool in detail, but let me take you that how these ontological terms relate to each other. I tried to create something called, subject category, Library of Congress subject, and then there is a GIPP profile, Web of Science subject. So 3-4 models are there. I tried to create an ontology for all these subject categories. It is quite interesting that if you categorize like mechanical engineering, it may appear somewhere in GIPP, it may appear somewhere in some other places in Web of Science, but the content is same. So whatever style you are using, we finally get the exact data. That is what is that semantic web. And this is a screenshot of that, how I created it. Here you can see that I work with Shodhganga. I try to create with the departments, researcher, guide, universities and all that, and one guide may be leading many people. So relations are spelt there, so that if people can go to one guide and see all his research supervisor. So we try to create an ontology for the Shodhganga. That is what is given here. But in that subject, how I handle, just I want to show you with the help of. Let us see one tool. There are so many software tools to create ontology, OWL or RDFS. Very important, very popular ones are Protege, Neon Toolkit, Jena. Jena is a Java based one. All these are used for creating OWL. Now let us see the screen. I'll just go here. This is what is called, this is Protege OWL plugins and all that. Now I tried to open an RDFML. I don't want to cancel it. I have already opened it. Now I created one domain called thing. Thing is the top domain. In that I am giving 3-4 subject categories. DCC, decimal classification, GIPP, Library of Congress and Web of Science. Now GICC, I have this classification of subject, and DCC, this stands for decimal classification scheme. We form this classification scheme here. Here the subjects are given here. Here it is called GIPP. Then LCSS, that is Library of Congress subject catalog. Then we have the Web of Science. Web of Science I have not added it. Now if a fine arts is there, I took fine arts here. Now all these humanities, I take humanities, and there are version that this is connected to both. Some of the things this may be connected to both. So I create here a relation that this is also part of this. Now let us see how this will look like. It's very interesting I am using a kind of ontograph here to see the visualization of ontologies. I can make it anyway, and this is how, here you can see friend of friend, a concept like a social media. If you are using, how background they are managing that you have a friend, he has another friend, and all these interlinked. You may like to add him as a friend. It gives a suggestion. So the background of Facebook or social media website, LinkedIn, etc., they use the concept of FOAF, friend of a friend, concept in the background. So similarly, we try to define something on subject here. See here, this is very interesting. I can manage anyway, and finally I save it as a OWL file, save as, and I can put it as RDF or OWL, RDF XML or OWL XML, or whatever way I want. Save it as, and once I save it, I can upload to a common website where others can share this kind of ontology. So this is a subject ontology I created. This is how semantic website work. So once again, semantic is giving meaning to the existing web. It's an extension of the existing web, and the data can be related inside and by the machine, and machine can try to understand the data, and the interchange of data is possible in semantic web. The future of website is semantic web. Thank you very much for patiently hearing me.